Let us find the sum of the summation of, here we have inverse tangent of n+1 minus the arctangent of n. N starts from 1, goes to infinity. Very well. So what I'm going to do, I'm going to expand this series. Let us expand the series to see if we have any behavior that we can recognize, to see if we can recognize any pattern. So if n is equal to 1, you get inverse tangent of 2 minus inverse tangent of 1. If n is equal to 2, you get inverse tangent of 3 minus inverse tangent of 2. Well, if n is equal to 3, let's see, you get plus inverse tangent of 4 minus inverse tangent of 3. If n is equal to, for example, 4, you get inverse tangent of 5 minus inverse tangent of 4. Let us stop. If I continue this process and take a look at these initial terms, what I see here, I see, okay, I have inverse tangent of 2 and inverse tangent of 2 opposite. So I can cancel these two out. I can cancel out inverse tangent of 3, negative inverse tangent of 3. So basically, I can cancel out all of these terms. So if I write the rest of the terms, I end up with, I'm using S sub k, which is the partial sum. Remember that. Later on, you're going to take the limit of the partial sum. So if I continue this process, the last two terms are arc tangent of k plus 1 minus arc tangent of k. But from the pattern that I'm seeing, I'm getting rid of all of these terms, right? Arctangent of k and arctangent of negative k, which is the term before it. I can cancel these two out. So S sub k is nothing but inverse tangent of, or arctangent of k plus 1 minus arctangent of 1. Now take the limit of the partial sum to see where does it go. Take the limit of S sub k. Here you have the limit of S sub k as k goes to infinity, which is the limit of arctangent of k plus 1 minus arctangent of 1 as k goes to infinity. But remember the behavior of arctangent. Now we are going back to pre-calculus, right? From pre-calculus, let me use a different color. The behavior of arctangent was like this. If you look at the arctangent function, the behavior is like this. As x goes to infinity, your function is getting closer and closer to this horizontal line, which is pi over 2. If you're getting closer and closer to negative infinity, it's getting closer and closer to negative pi over 2. It approaching negative pi over 2 and the other direction, everyone, not the same direction. So this guy, the limit of arctangent of infinity is pi over 2. Also from pre-calculus, you know that inverse tangent of 1 is pi over 4. And also let me write this guy down here. If y is equal to arctangent of 1, it means that you're looking for the y value that the tangent of that y value is equal to 1, but that y is equal to pi over 4. So you get pi over 2 minus pi over 4. So the limit of partial sum as k goes to infinity is equal to pi over 2 minus pi over 4, or here you have 4 pi over 4, sorry, 2 pi over 4 minus pi over 4, which is pi over 4. So the series is convergent to pi over 4. So if we add the terms of the series, it is convergent to pi over 4. So let us summarize what we did here. We are finding the sum of the following series: inverse tangent of n+1 minus inverse tangent of n starts from 1, goes to infinity. We decided to expand the series to see if we can recognize any pattern. This is basically another telescoping series that you have. So here, if I plug in 1, I get inverse tangent of 2 minus inverse tangent of 1. If I plug in 2, I get inverse tangent of 3 minus inverse tangent of 2. If I plug in 3, the same process. So I see a pattern here. I can get rid of opposite terms, and I can simplify S sub k to basically the difference between arctangent of k plus 1 and arctangent of 1. Now I need to take the limit of the S sub k. To find the limit of arctangent of k plus 1, this is basically going back to pre-calculus and checking the graph of arctangent. As x goes to infinity, your arctangent is getting closer and closer to pi over 2. And then to find the arctangent of 1, arctangent of 1 is equal to pi over 4. Because to calculate arctangent of 1, you're basically finding the tangent of the angle that is equal to 4. That angle is pi over 4. So here you have pi over 2 minus pi over 4, which is pi over 4. So the limit of the partial sum as k goes to infinity is pi over 4. By the definition, we conclude that the series converges to pi over 4.